In this set of problems, we're given the information that the probability that a store will recover stolen merchandise is 15%. And in each problem, we're given the information that there are 200 stores. So n is equal to 200, and this is a binomial problem because either they recover the stolen merchandise or they don't. So we're going to use either the binom PDF function in these problems or the binom CDF function. And you find both of these functions by pressing on your calculator second and vars, and then you scroll up until you find the one that you want. Now in number 28, we want the probability that out of 200 stores, exactly 28 of those recover the stolen merchandise. So since it's a precise number, it's not a range of values, we want to know just the probability of exactly 28 recovering the stolen merchandise. So we're going to use binom PDF for that. So you use PDF when you just have one single number that you're finding the probability of. And we enter N and P and the value that we're looking for, 28. And so I have that typed into my calculator, and this turns out to be 0.0748 rounded to 4 decimal places. In the next problem, number 29, we have the same scenario, but now we want the probability that more than 40 stores recover the stolen merchandise. So in this case, what I'm going to do is I'm going to say to myself, well, we're looking for the probability of what? If it has to be more than 40, then that means anywhere from 41 all the way up through the maximum number, which is n, so that's 40 to 200. I'm not subtracting there, I'm just saying it's the range of values from 41 to 200. The calculator won't do this. The calculator will only work this type of problem if there's 0 in the first position there. So what we're going to do is we're going to use what we know about probabilities. We're going to say, well, the probability of falling anywhere from 41 to 200 is the complement of 0 to 40. So now we're starting at 0, so I can put this into the calculator. And this is a range of values that we're talking about here, probability of 0 up through 40. So we're going to use binom CDF. And again, I enter N and P. And then, now since I have this in the regular format that the calculator wants, 0 up through a number, I put in that number 40 for my upper limit. So we've taken care of the fact that 0 to 40 isn't really what we want by subtracting from 1. So now if I put this into the calculator and round to 4 decimal places, I get 0.0220. And that's my final answer for number 29. Next, number 30. Same scenario again, but now we want at most 27 stores to recover the stolen merchandise, or we want to know what the probability of that is. So at most 27 means anywhere from 0 up through 27. So in this case, we're starting at 0, which is what we want. So I can just go ahead and do binom CDF 200, 0.15, and 27. And when I pop that into the calculator, I get 0.3166, rounded to 4 decimal places. In 31, same scenario. Now we want to find the mean, and we can do this by using the formula mu equals n times p. This is actually given on the front page of your exam. So n is equal to 200, p is equal to 0.15, and we get 30 stores that we would expect to recover their merchandise on average in this scenario. And in 32, now we want the standard deviation. Again, this formula is given. Sigma is equal to the square root of n times p times 1 minus p. So this is 200 times 0.15 times 1 minus 1.5. And when you put that into your calculator, you get 5.0498. And that's my final answer. So that's how you would work those 5 problems.